So the robotics industry. Um, Boy, that's a loaded deal. I talked about this a little bit because Jerry is addressing many of the problems of the robotics industry. But let's see. I'll start at the beginning. The robotics industry has existed for almost 70 years now. Unimate was what I really considered one of the first real robots because it was a programmable machine. It's not technically a real robot because it couldn't really sense anything and it couldn't really do very much, it wasn't a thinking machine. It was an improvement on automation in that he had a reprogrammable computer. But now any kind of machine or smartwatch has a reprogrammable computer, so what is a robot? I think of a robot as an artificial organism. So if it's not something that you can consider as an entity of some kind, if someone automatically goes and wants to call it a he as opposed to an it, if it doesn't do that, then it's not a robot to me. And the industry doesn't really care. The engineers and the roboticists who work in the industry, that's not what they're looking at. But robotics today is very much more of an academic pursuit than actually an industrial pursuit. It's still a pure science. Robotics is still a science. It's not a discipline. It's not something that people just go and kind of pick up, I would say. It's very much an academic-based industry or category. So that's where robotics is right now. What I think is interesting with robotics is that since the 1980s, people have been saying robotics are right where the personal computer are. They're just about to go over the hump and they're just about to take over the world. And they've been saying that for 20 to 30 years. And it hasn't happened yet. I think a part of it was robotics hasn't really taken over the world because the internet came along and then the smartphone came along and all of these kind of stole the thunder and the talent from what robotics was doing. But whenever that was said in the past, the robots that existed were not products. They were robots that had increasing abilities, but they were never products. They were still something within the lab, and I don't think you can use the lab as a comparison for any of this stuff because a lab doesn't translate immediately into a product. It doesn't even matter if it's in MIT because there's so many other factors that influence the creation of a product from some academic research project. When I got into the space, when I got into the space professionally, as in basically the last 3 to 4 years, robotics was still an academic pursuit, but it was just the technologies to create a robot were becoming accessible and cheap enough, all of them. The motors, the processors, all of it. And the computing, the software and computing know-how had become open source. Technologies like OpenCV, or organizations like OpenCV and the Open Robotics Project, all that kind of stuff. All of those create an ecosystem where somebody like me can come together and pluck together different parts and stick them together into a single machine that's useful. So that's something that's only happened really recently. But the robotics industry is still incredibly fractured. And it's not organic, and there's no foundation. There's nothing to build up from. And if you want to get into robotics, you go get an engineering degree in robotics or a computer science degree in robotics, and you independently create a full machine. There's not very many platforms out there. There's no platforms out there. So how can we expect this industry to improve and grow on itself if everybody's starting from square one every time? So that's an issue with the industry right now. There's not really accepted standards, at least within the development of complex robotics. And if you go into industrial manufacturing and those kind of robotic systems, it's a little bit better because those have to be standardized and factories have to know what's going on and they have to be well documented. Whereas robotics in general is not like that at all. If you're creating what I think of as a robot as an organism, it's not like that at all, because you can use a Raspberry Pi or you can use your custom-made PCB or whatever it is. Everything can be made from scratch. And robotics is so multidisciplinary that it's really hard to create a foundation like that, because there's no, like, where do you start? Do you start with the psychology, the neuroscience, the computer design, the software design, the mechanical design, all this stuff? Because these are all the factors that go into robotics when you're creating a robotics product. So that's the main issue with the industry. Within the technology of it, and how the industry approaches robotic design and its capabilities, I would say that old habits are still hanging on, in that when you create a robot, it's still common practice to program every rule about the world into that robot. There's no organic learning method so that the robot can basically figure out what it is. And you plug in a chip and the robot knows what it's doing, as you would turn on a smartphone and it immediately goes into its operations and doing what you wanted, and you download an app or something. But, oh, that wasn't a very good way of phrasing that. Let me try this again. If you build a robot, the expectation is that you do all of the math and inverse kinematics and all the math. I'll say all the math. I'm not going to list all the math that you need to do. But do all the math to figure out what that robot is and define that robot's body for it. You tell it where its finger is when it's got its elbow turned at this point or whatever else it is. The robot is not a thinking machine. You are attempting to create the most complex clockwork you possibly can. And today we're smart enough with our mathematics and computer simulations that we're able to do that. But it's a very poor design choice because it offers so little flexibility. Because when you're creating robots, robots have the capability to be any kind of machine or organism or alien. To have to completely define a system and create all the rules for it each time you create it is too low level. It's like redesigning a microchip from transistors. That's almost what it is. So within the technology, roboticists and I'll say roboticists, anyone working in the robotics industry needs to attempt to move away from that and figure out how these robots can build themselves. You upload a basic program and the robot basically figures out what it is, and it's like it learns itself like a baby, like an infant growing. It figures out what it is. And this has been a very difficult problem because machine learning and neural computing and all that kind of stuff has been a difficult challenge, but it's finally possible with the cloud. And even Google, if you took Google's deep learning projects and applied them to robotics, many of the robotics industry would be unemployed, because so many of them are software developers who are defining these robots into a very finite amount and creating the control algorithms and all that kind of stuff. But if you allow the robot to figure it out on its own, you will create much better solutions, first of all, and you will also be faster and more adaptable and configurable than we've ever been before, and that would be the foundation. If I was to point to what should be the foundation for robotics, I think that would be it. The creation of software or a computing process that an engineer can immediately apply and skip over all the low-level kinematics and controls, because those are what slow it down so much right now and are still very hypothetical. Or no, not hypothetical, theoretical. But if you want the industry to grow, you have to bring it back from trained engineers and PhDs and that kind of stuff, so that a more average person can do something with them. But very likely a more average person will just create the solution that those guys are not providing in a more flexible robotic system. As far as the mechanical design of robotics goes, it's an open-ended field, so there's no way to express a feeling about that. It's like saying, what is your favorite animal? There's so many of them that it's almost impossible to choose. And they're going to be more diverse than biology has ever been as far as robotics goes. So that's my thoughts on robotics as the industry as it stands right now. So I'll let that go right there.